Okay, at the end of last video, we noted that Hume either needs to reject perceiving or find a different argument against induction. And in this video, what we'll do is ask, is there a better argument against induction? We'll find that there is, and then we'll show that it's not going to save the position that perceiving is good, but induction isn't. So how does this go? Well, consider the following passage from Bertrand Russell. So Bertrand Russell initially, in his philosophical thinking, claimed that anybody who rejects induction is insane. And his idea here was that everybody needs to rely on induction every day. And we've talked about this before. When you show up at the classroom, instead of, I don't know, driving to Montana for the class, it's because this is where the class has been before and you expect things to go on as they've been going on before. When you sort of like turn to your right and you see what you expect to see rather than a fiery volcano and demons and so on and so forth, it's because you expect that what's to your right will be like what's been to your right before. When you've looked to the right before, you've seen, like where I am right now, I see a white wall with some writing on it because it's a whiteboard wall. I don't turn to and if I look to the right again, I look back, I see the same thing each time. So I expect to see it next time. I can even know that I'll see it next time. I can look to my right if I want to see what's on the wall. I don't expect to see something totally different. That's why Russell said that rejecting induction amounts to insanity. It amounts to never being able to sort of say what will happen next or to predict what's happening elsewhere based on what you've already seen. But Russell later says, I came to the conclusion when thinking about induction that inductive arguments, unless they are confined within the limits of common sense, will lead to false conclusions much more often than true ones. The limitations imposed by common sense are easy to feel but difficult to formulate. Now the question is, why does he think induction needs to be constrained by the limits of common sense? And to get an answer to this question, let's consider some examples. We're now going to look at a website put together by Tyler Vigen based on some explorations that he did. And basically what he does is this. He takes large data sets and he has a computer just sort of look for correlations between the data sets. And then he publishes the correlations. And as you'll see if you look through this website, it was basically from 2000 to 2010 or 2009 that he took the data. So he took data from that period and said, just go out and find correlations. And what he found is the vast majority of correlations that get found are meaningless. So for example, there's a 95% correlation between consuming cheese and dying by becoming entangled in your bed sheets over that period. And the point isn't that consuming cheese causes you to become entangled in your bed sheets. The point is rather that sometimes things go together just by chance. There's a lot of different things out there. Some of them are going to correlate by chance, like per capita cheese consumption and number of people dying by becoming entangled in their bed sheets. In fact, most of the correlations are going to occur just by chance. So let's look at a couple of others. We have a 99.26% correlation between divorce rates in Maine and per capita consumption of margarine. So these go together really tightly. But consuming margarine doesn't cause divorce in Maine. Getting divorced in Maine doesn't cause consuming margarine. And there's no single common cause for both. It's just chance that they go together. Age of Miss America correlates with murders by steam, hot vapors, and hot objects. Very nice and tight correlation. Of course, presumably you'll have a fairly small sample size for the murders by hot steam, vapors, and so on. But the point is, when you look at this correlation, or you look at the one about divorce rates and margarine consumption, or you look at the one about cheese consumption and becoming entangled in your bed sheets, or let's look at one more, total revenue generated by arcades correlates with computer science doctorates awarded in the US. You're not going to infer that one of the things at issue is causing the other, okay? Instead, what you're going to infer is nothing. You're just going to say, it's just chance. But if you were stuck with induction, unconstrained by common sense, if you always had to assume that what you haven't observed yet resembles what you have observed already, then you would expect this correlation to hold going forward. You would expect that in 2010, total revenue generated by arcades will correlate with computer science doctorates. You would expect that in 2010, divorce rates in Maine are going to correlate with per capita consumption of margarine. Moreover, you would be able to say, look, if you got divorced, if lots of people got divorced in Maine, then there's going to be more eating in margarine, more eating of or less eating of margarine. You're going to have to assume that these things go hand in hand if you don't constrain induction within the limits of common sense. But of course, you shouldn't assume these things go hand in hand, so you should constrain induction within the limits of common sense. Now, you can think of this as an argument, this correlation after correlation, as an argument in favor of, an argument against induction. What the argument would go like this. If the vast majority of correlations are spurious, the vast majority of correlations are meaningless. If you just use induction, you're going to have to say that they're all good. You'll have to say that every correlation is equally good. But then the vast majority of conclusions you draw by using induction are going to lead you to false conclusions. And if the vast majority of conclusions you draw by using a method of inference lead you to false conclusions, then it's not a good method of inference. Therefore, induction is not a good method of inference. Russell suggests something else. After all, the difference, if you reject induction, he thinks you're insane. So what does he suggest? He suggests constraining induction within the limits of common sense. When you see a correlation between smoking and cancer, you can infer that smoking causes cancer. But when you see a correlation between the number of people drowned while in swimming pools and power generated by U.S. nuclear power plants, you're going to say, that doesn't make any sense. Common sense tells me that's not meaningful, so you're not going to infer that there's a causal relation or between the two or a common cause. Okay, so there's Russell. A potential argument against induction says it will usually lead to false conclusions. Russell's solution is constrain induction within the limits of common sense. But then there's a question that arises. How can we constrain induction within the limits of common sense? What can we do? And Bayesian inference promises to do exactly that. Accordingly, whether or not reasoning is a good way to form beliefs might depend on the value of Bayesian inference, and moreover on the value of something called Bayesian inference with subjective priors. And in the next video, we'll talk about what that is and how it works. We'll start out talking about Bayesian inference with objective priors. We'll then talk about Bayesian inference with subjective priors after distinguishing objective priors from subjective priors. Okay.